Hello, my name is Darius Pupeikis. I am from Kaunas, Lithuania. I am going to introduce the project called Kaunas Digital Twin. My background is civil engineering and I am a representative of Kaunas University of Technology, Faculty of Civil Engineering and Architecture. My main scientific field is related to building information modeling, digital twins, and building data science. And my current position is the head of Center for Smart Cities and Infrastructure. It's the university's department, which mission is to build, sustain, and develop a community focused on smart cities and infrastructure. The project Kaunas Digital Twin is a continuous project, which is being developed together with CSCI partners and industry leaders. The project Kaunas Digital Twin is focused on the digitalization of built environment by giving an emphasis on the university campus, all town and central city areas. The main project's platform is Bentley's Open Cities Planner and currently accommodates the results of research and study projects. Our main achievement and ongoing goal is to integrate different digitalization technologies of the built environment by applying them to practical real-world tasks. Let's dive into technology and discuss about two states of digital twin. The first state represents existing situation of physical environment. The Kaunas Digital Twin implements state-of-the-art digitalization technologies such as photogrammetry, LiDAR, thermophotogrammetry, and 360 panoramas. The next one is BIM, which appropriate to distinguish into 3D model and attribute parts. This framework shows common digitalization technologies, which we are focusing on. I would say that each technology has its advantages and disadvantages. For example, we used reality capturing technologies, which are good in geometrical representation, aesthetics, and speed of digitalization aspects. However, it's poor in semantics. I mean, usually for meaningful digital twin, we need high-level machine-readable, standardized, and structured data. BIM is slow, but gives huge opportunities concerning semantics, attributes, classes, distinct elements. IoT and various APIs are unique in dynamics, which could provide periodically updated data from any sensors, device, or equipment. It's popular to store data in a database and spread it through standardized protocols. Finally, we can't avoid historical data, which is usually CAD-based and without affordable machine readability. Anyway, during the past decades, humanity collected much data about the built environment. The next state is the future state, which is related to forecasting future events, actions, and behavior. During the implementation, we simulate some shading effects of our solar panels, people movement, building energy performance, flooding. Also, we use data analysis and machine learning-based algorithms for forecasting thermal energy and electricity consumption. Point cloud clustering we use, for example, for segmentation of buildings and for distinguishment from a terrain. Now let's illustrate some of the use cases. For example, the flood simulation carried out with Bentley's Luminar-T software allows for the assessment of potentially risky areas in the territory, and on that basis preventive decisions could be taken for the protection of buildings, utilities, or other objects. The impact of shading on PV solar panels is a significant factor in achieving efficient electricity generation. In this case, a reality capture serves as a guide for the possible placement and orientation of the panels on horizontal, angled, and even vertical surfaces of the built environment. Indoor air quality monitoring is an important factor to ensure efficient use of thermal energy, supply of fresh air, and maintenance of optimal relative humidity. Based on the results of the monitoring, adjustments to the HVAC system could be made in premises or zones. And geometric measurements, which can be useful in a wide range of situations. But based on our experience, it is important to have an assessment of the geometric dimensions of the building when it comes to renovation. Dimensions provide the basis for the production of customized prefabricated building elements, thus significantly reduce construction time. This building is called MLab. it's a prototyping laboratories, one of the most modern buildings on the KTU campus, which is part of Kaunas Digital Twin, and for which the CSCI team has carried out various digitalization activities. We used Bentley's Open Buildings Designer for BIM modeling by focusing not only on creating a geometric representation of the architectural, structural, and MEP systems, but also on the semantics, I mean standardized attributes. As well, it's worth to mention that this BIM model is classified according to the National Construction Classification System. Particular attention is paid to proper export to the IFC format by checking and linking classes, types, and their properties. Also, we have used the YII2022 platform to integrate BIM, IoT, and API data to develop an algorithm for predicting thermal energy consumption by using machine learning algorithms. Currently, linear regression and XGBoost machine learning methods were used for the forecast. However, any AI approach could be implemented. Bentley Legion software was used to simulate the evacuation of people from a building. This way we can see the risk areas where people are crowding and take preventive actions, such as distributing the flow evenly according to the capacity of the exits. Let me allow to introduce more implementations within the OCP platform. Thermal photogrammetry, the technology which enables the creation of 3D thermal model that can be used to assess the heat loss of the building or the thermal energy performance of an entire block. The 360 panorama technology allows for visual representation that can be useful in asset management, seeking of construction progress, or other use cases. In an urban context, it's a useful technology to provide more information about the building indoors. Integration with BIM enables projects to be presented to the public, evaluated in an urban context, or for seeking a construction progress. In the future, we can see very useful integrations using a semantic part of the models. E-modernization is another Kaunas Digital Twin sub-project, which aims to assess a residential neighborhood as an independent energy island, using 3D model data and integrating the results into digital twin. For this purpose, calculations were applied for the use of different energy sources, assessing the consumption of economic aspects of solar energy, heat pumps, electricity grid, and centralized heating networks. As I mentioned before, the main Kaunas Digital Twin platform is the Open Cities Planner, which we believe has progressed significantly in the last few years. Various integrations have emerged that have allowed us not only to host reality capturing data, but to integrate some subsets of BIM models and stream data through HTML embeddings and other sources. For reality capturing purposes, we use drones, lidars, cameras, and Bentley's context capture family software. For BIM and 3D modeling, Open Buildings, MicroStation, and a couple of other tools we have been using. Zabbix, it's our middleware for femtosensors and Arduino sensors, data integration, storage, and streaming. Python and related packages as Pandas, Scikit-learn, TensorFlow we used for data analytics and machine learning. And finally, YII2022, which we started using 2 years ago, attracts developers and seeks interdisciplinarity between information technologies and civil engineering fields. Let's summarize some points. The main challenges we faced basically are related to interoperability, the lack of implementation of standardized data formats into the software, especially the semantical part. However, in this case, YII2022 helped to deal with these issues because it has strong customization capabilities. Next point is the interdisciplinarity. It's crucial for the development of digital twin. For the built environment, it is important to have experts in the field of civil engineering, architecture, IT, facility management, data science, etc. Only an interdisciplinary team could achieve valuable results. They should work hand in hand. Think with end in mind. Use cases should be identified at the beginning, but in parallel with an assessment of the feasibility of implementing them. Looking from a technological perspective, digital twin is a combination of different digitalization technologies, which have their advantages and disadvantages. It is important to focus on the strongest sides of a particular technology by applying it to a particular use case. And finally, take advantages, not the issues.